again, we're looking at triangles, and the name says it's tries, three angles, three angles. So like I said, I have a triangle, and I just painted the angles, right? I just came over and painted. The angles are going to be very important. So as a matter of fact, on my paper here, let me cut out my three angles. I'm going to cut them out. I don't care about the rest. And as a matter of fact, let me take them, put them all together. There's one. There is the second one. And there is the third. So in a way, obviously mine here in class is a little twisted. When you guys see something like this, right? What I have up there. Alright, I know we measure the angles of the line. We talk about, when we talk about angles, I talk about acute, right, obtuse, and straight. So I know this is a straight angle. How many degrees is a straight angle? 180. So the three angles of a triangle, when I put them together, they make 180. So that's one thing that we're going to learn. So do me a favor and write that thing down. The measurements of the angles of a triangle add up to 180 degrees. I wrote a couple examples in there. If you guys add the numbers, it's 180. The measurements of the angles of a triangle add up to 180 degrees. In fact, down the road, we're talking about a third, fourth quarter, we're going to be talking about some special right triangles. And they're special, the measurements are going to be 45, 45, 90. And then we're also going to have that 30, 60, 90. Right, the numbers I mentioned is just talking about the degrees of the triangles, but if you add them, it's always 1/8. Can I erase it? Or can I take this off? No, just the two examples I just gave it to you guys, but just write that sentence basically. If you guys want to draw the examples, then go. Alright, so then, now let me talk about the exterior angle. If you notice, I have a triangle, but then I have an angle on the outside, which is we're going to call it exterior. My exterior angle is 130. If you notice, my angles A and B are 70 and 60. What can I do to angles A and B to come up with this 130? Add. So do me a favor and let's write the measurement of an exterior angle of a triangle is the sum of the two non-adjacent angles. So I drew an example. If you guys want to draw the example to help you guys out, even better. And I said to help you guys out, because remember the final for the first semester, and I'm talking about December 22nd, we'll have this. So probably tomorrow you guys will remember well, but late December, you might not. So write it down. The measurement of an exterior angle of a triangle is the sum of the two non-adjacent angles. In my example, 130 equals 70 plus 60. And I know we talked about the word adjacent before. Adjacent means next to. So non-adjacent means not next to. Right? I see my exterior angle. My adjacent angle will be this, the inside of angle C, plus C. So my adjacent angle will be the inside of angle C, but I'm saying don't add it to that. I'm saying 130 will be the sum of the other two angles. Okay. Can I erase it? Not yet. So remember, the measurement of an exterior angle of a triangle is the sum of the two non-adjacent angles. And then we're going to learn how to classify triangles by the sides and by the angles as well. So first, let's classify a triangle by its sides. If all the sides are the same, we're going to call it equilateral. So if all the sides measure the same thing, we're going to call it equilateral. If two sides are the same, then we're going to call that isosceles. In this triangle, also two angles are equal. And all sides are different, we're going to call that scalene. So you guys will measure triangles. You guys will get the three measurements. If they are all the same, we're going to call that equilateral. If only two of them are the same, then we're going to call that isosceles. But if they're all different, we're going to call it scalene. Once again, I'm going to ask you guys to classify the triangles by the sides. You measure the sides, and then you name it one of the three, depending on the measurement. So if all sides are the same, we call that equilateral. Two sides are the same, we call that isosceles. If they're all different, we call that once again scalene. Okay, so Naomi's absent. Go back to your seat. Have a seating chart for research. So all sides are the same, we call that equilateral. So matter of fact, equi sounds like equal. Lateral is sides. So that thing says equal sides, equilateral. So matter of fact, the interesting part about equilateral is also equiangular. Once again, equiangular is angle, so it's all equiangular. So I'm saying the three angles measure the same, but I know they all add up to 180. So how many degrees will each of them be? Right, there's three angles, they all add up to 180, they're all the same. So how much each of them will be? The measurement of the degrees? 6. Nice. Right, so for an equilateral, the measurements of degrees are 60. Right, they're all the same, they all add up to 180. For isosceles, only two angles are the same. The third one could be different. And for scalene, the interesting part, all the sides are different, but also all the angles are different. Alright, let's classify a triangle by its angles. Alright, so once again, for sides, we have three names. For angles, give the triangle the name of the biggest angle. And then we know acute is less than 90, right equals 90, and obtuse is more than 90. Right, kind of like our angles that we learned last week. So give the triangle the name of the biggest angle. So we're going to have some acute triangles, some right triangles, and some obtuse triangles. Right, I'm looking for the biggest angle of the group. And if they're all the same, right, 60, 60, 60, obviously the biggest number you see there is 60, so that would be an acute triangle. The biggest number from the three angles, in that case, it's 60. Once again, for the triangle, give the triangle the name of the biggest angle. You can look for the biggest angle, and that's pretty much it. Alright, so remember, acute is less than 90, right is 90, and obtuse is more than 90. Okay, I take this up now. Okay. Alright, for perimeter, for the perimeter of triangle, add up three sides. When you guys see my triangle there, side 1 is 50 centimeters, side 2 is 15 centimeters, and side 3 is 18 centimeters. What will be my perimeter for this triangle? perimeter. So add all three sides, 15, 15, 18. How much is that? 48. Nice. So 48 in this case, centimeters. 48 centimeters because we're adding the three sides. And then you mentioned isosceles, and yes, this will be an isosceles triangle based on the sides. Just write down the top line for the perimeter of a triangle at all three sides. Okay, perimeter. If I'm looking at this was a yard, a backyard, the perimeter is the fence. So perimeter. The inside, so the grass, that will be the area. The perimeter, just look at the fence of the backyard, right? Just the outside. But before we do this, let's talk about rulers, because we're gonna measure things. But let me talk about how to measure using a ruler. Sounds like it's so simple, but it's a little more complicated than it looks. All right, one side we have centimeters on the top. In my case, the top and inches at the bottom. From between each number on centimeters, so if you guys want to between 1 and 2, or between 2 and 3, between each of them, how many spaces do you count on centimeters? Not nice. So they go 1, 2, 3, 4, 5, 10. All right. So if I was to, so I'm gonna use a decimal system. So if I was to go with 2 in 3 spaces, I'm gonna call it 2.3. Right? If I go 2 and then 7 spaces, call that 2.7. But on inches, it's a little bit different. How many spaces do you count between a number and the other? Like between 1 and 2? Like count the spaces between 1 and 2. I'm getting different numbers. I heard 7, I heard 14. No, I'm hearing 16. Let's count it. I want to count the spaces from 1 and 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in inches, it's broken down to 16 spaces. So I'm going to use fractions for this. Let's say I was to go 2 in 3 spaces, I will call it 2 and 3 over 16. Right? 3 over 16. I'm not going to go 2.3 for inches. So to practice, I have the same measurement for centimeters and inches. If you notice, I go up to, like, in centimeters, I go 6 and, what's that, about 9 or 8? So 6.8 for centimeters. So centimeters is measured, it's easy to measure. But on inches, I go 2 and, how many is it? This is like 12, right? After 2, I count 12 spaces. So 12 over 16, simplify your fraction. So 2 and 3 quarters. Right? 12 over 16, it's 3 over 4. So I'm going to call this 2 and 3 quarters. If you notice, inches, they also broke down into 1 quarter, 2 quarter, 3 quarter, 4 quarter. They made those a little bit bigger. Alright, so this is 2 and 3 quarters. Let's take a look at another measurement. In centimeters, how much is that? So 8.7. So 8.7. Now in inches, how much is this? 3 and 7 16. Alright, so like I said, ruler it's easy, but inches is a little harder than centimeters. Alright, now that we measure this, let's talk about the area of the triangle. So do me a favor and write that thing down. Area is equal to 1/2 the base times the height. So area is equal to 1/2 base times height. in mind though, the base and the height are two measurements that cross 90 degrees, but also keep in mind the height goes to the highest point. So in your homework, you guys will have to draw the height somewhere in here. So looking at the homework, let me take a look. On the front side first, let me move up to the front. By looking at the homework, the first part, it's only 3 questions up front. Measure the side length. So there's 3 sides for each triangle. Measure the side length in inches and centimeters. So write down how many inches, write down how many centimeters for each. I have a few rulers I can let you guys borrow. And then measure in angles, measure in degrees of each of the triangles, each angle. So each corner, measure it in degrees. You guys have your protractor to do that. Also, and at the end, measure the angle, label 1 for each triangle. If you notice, that's the exterior angle. If you guys see a resemblance from here, if you guys have all 3 angles of the inside, pretty sure you can find out. As a matter of fact, with 2 angles, given 2 angles, you can find the third one and the one on the outside. Alright, so that's what I'm asking on the front side. Any questions on that? Alright, now on the back side, there's also 3 questions only on the back side, but this one has a few more steps. First thing, measure the side length in inches and centimeters. Once again, measure each side in inches and centimeters. Then classify the triangle by the side length. So either equilateral, isosceles, or scalene for each of them. Then find the perimeter of each triangle. And use either inches or centimeters, the one that you wish. So find the perimeter for each. I would recommend you guys using centimeters. It's easier to deal with centimeters than inches. So write the number, either centimeters or inches. Then I'm asking you guys to measure the angles. So you guys can do that. Find the sum of the angles. For number 5, it should make sense with my notes. And then for number 6, find the area of the triangle using 1/2 times base and height. I notice we have a base, but we don't have the height. You guys will have to figure out the height. Right, it crosses a 90 degrees. You guys notice the corners of papers are 90 degrees. So what I will do, I will line up a paper to be able to mark my height. Remember, it has to go through B, and it crosses 90 degrees with AC. So I will use a paper to be able to line up my height and then measure the height, have the base, and figure out the area. Any questions?